Oh, hi SPU 30. It's me, Peter Hedman, and I'm here to answer the question, how can non-radioactive carbon isotopes be used to determine if a sample of carbon was ever from a living thing? Keep in mind that we're talking about non-radioactive isotopes of carbon. Those are isotopes of carbon that do not decay, that are stable. Carbon-14 is what we've talked about before, and it's a radioactive isotope of carbon that can be used to date when a living thing was last alive, but only for the most recent living things. We're not talking about carbon-14 today. No, instead we're talking about carbon-13, which is a isotope of carbon. It's not as common as carbon-12, which is the most common isotope of carbon and makes up most of the carbon in your body. Carbon-13 makes up perhaps 1% of the carbon in your body. The important thing is that chemical reactions tend to be biased against heavier isotopes. So every time a chemical reaction occurs, on average, more carbon-12 will be incorporated from the environment than carbon-13. Of course, the specifics of each individual reaction determine how strong this bias is, but in general, chemical reactions will tend to incorporate more carbon-12 than carbon-13. So how can we use this to determine if carbon was once part of a living thing? Well, what is life? What is life but an enormous series of chemical reactions? So if all of the carbon in your body has been processed through countless chemical reactions, from the atmosphere, from CO2 in the atmosphere, to carbon in plants, to all the different cells in your body, to proteins and lipids and all the different molecules that make up who you are and do all of the different jobs that life requires. If all of the carbon has been processed through countless chemical reactions, then this slight bias towards carbon-12 over carbon-14, I'm sorry, I misspoke, carbon-13, the slight bias of carbon-12 over carbon-13 will tend to accumulate. That means that living things, the carbon that was once part of living things, will tend to have much less carbon-13 than 12, and we say it is depleted in carbon-13. The way we express this is we might write down something like this. We might want to measure the ratio of carbon-13 to carbon-12, and then we see that this ratio is much smaller for living things because there's much less carbon-13 per carbon-12 in living things. And that's the complete story of how we use non-radioactive carbon isotopes to determine if a sample of carbon was once part of a living thing. So using this information, what would you do if you found a rock? And then inside that rock is maybe a dark layer of carbon. What is the origin of this carbon? You can figure out if it once originated from living things by testing its carbon-13 content.